and welcome to JAX 2016. We are here with one of our speakers, Mr. Davies. Thank you for joining us. And thank you for your session, very fruitful. I would like to start by asking, what do we sacrifice when moving from in-process to distributed?
It's like falling off a cliff. We go from working in the same machine, and the cliff is really the it's going out of the machine. It's predominantly serialization and deserialization. So what we take that works at, let's say, 100 units, all of a sudden works at 10 units. But we get all of the other machines to cooperate as well. So that very, very quickly builds up. So if we can scale linearly, those 10 units can be times 20. We start to see the benefits of distributing. So it is a huge cliff as we fall off.
Good example. And how can we move from in-memory to network or disk with little cost? That's very important.
Well, what I was talking about today was basically turning that into binary. The way Java serializes is horribly inefficient. The way Java stores things in memory is horribly inefficient. It's done for good reason, to abstract the operating system. But it's not been optimized throughout the entire duration of Java's 20 and a half years of existence. So putting it into binary is basically doing the same way as we did with C and C++. We create getters and setter classes around that, predominantly getters because we're just using immutable data, unchangeable data. And when we serialize and deserialize, there's no work to be done. We don't need to translate it. So what we have in memory is exactly the same as we put onto the network. So we get distribution with virtually no cost at all. And
maybe there are some other advantages of binary, of using binary?
The biggest advantages are it obviously uses a lot less memory. You could argue memory is relatively cheap. Another advantage is we can actually write it to disk and read it from disk, and so when we run out of memory, we can actually use the disk. There's plenty of very high performance disks available, SSD for example, and better. We can actually use the disk to extend our memory with virtually no impact at all. It's sort of 50% to 100% impact, whereas with normal serialization, it's tens of thousands of percent. So it could be 50 to 100 times slower or worse. So the binary gives us the advantage of smaller memory usage, so we get vastly more objects into memory, and we can also extend out to disk with very little cost, and of course, as we spoke about a second ago, into a distributed environment as well.
You also mentioned Spark during your talk, so what's your take on that?
Well, if you'd mentioned Hadoop, I would have said I hate Hadoop. I think it's one of the worst things that came around and was introduced to the world. But things have progressed, and we're into Spark, and Spark is a lot better, more sensible implementation. One of the problems with Spark is it's actually very efficient if you run it on a single machine. But again, one of the issues is as you run out of memory, we instantly hit the barriers that I've spoken about before, the cliff. And the differences in performance are hundreds of times slower as we hit disk and or network. And so putting this into binary, we can actually scale across multiple machines or into disk with very little cost, no more than 100% cost, i.e. it's less than half the speed. So it really does mean that we can scale using Spark across a distributed environment with tremendous performance.
But people are still using Hadoop.
People are still programming in COBOL and using. So, there's a lot of things that come around hype. You know, it has its uses. I mean, there are implementations where it has its uses, but things can be optimized far quicker. And I think going through the history, we've gone from relational databases into messaging. As we've become globalized, the messaging itself has resulted in the need for hierarchical and NoSQL databases, and then they realized they can't query those, so they've created yet another relational database, which is in the form of Hadoop, so they can actually go around and query it. So we've gone through this sort of full cycle, and it's not the most efficient way of doing it. And it's like most problems, you can look at it and think about it a little bit more, Hadoop is just not a very clever way of doing it. Spark is finally the progression. Hadoop's been around for a long time now. Spark is a more intelligent way of doing it.
And how about Arrow?
Arrow is interesting. Apache Arrow is an implementation very similar to what I've been talking about. So personally, it means that what we're doing, there's Project Tungsten as well, is other people have had the problem. So it's good to see that there are open source versions of that. What we've been doing is closed source and commercial, and I've been promoting the concept of it and seeing open source implementations of vastly more simplistic, because they work on a flat data structures where we've gone into the sort of hierarchical structures as well. It proves that there is an issue and a problem, so it's good to see.
Is there anything else that you want to talk about and we haven't covered?
Oh, the opportunity.
Or during your session, if there is something that...
No, we've, talking about buzzwords like Hadoop, one of the latest ones, certainly coming from London, is blockchain, and one of the keynote that I'm about to go to shortly is on blockchain. We've started to implement the binary implementations into blockchain as well, so I think that's quite exciting. So we've got a binary implementation of a blockchain. It's not really the blockchain, which I think is the exciting part, because it's basically just a linked list with hashes on it. So that's, my children could implement that, but it's the smart contracts behind it. And there's lots of violations of smart contracts if you start to extract data out to use Hadoop with, for example. And by keeping the excesses and using something like Spark or some other linear analytics with binary implementations, you get better distribution, etc. So I'm quite interested to see what the keynote speaker is talking about, and will be, as you probably know, doing the JAX finance keynote on blockchain myself next week. So, so that's of great interest to me.
Looking forward to it, and thank you for the interview and for the session.
You're welcome. Thank you.